Students and parents, thank you for joining our live session.
I can't believe that you came into my life. You made me feel again. Now it's my turn. You say you've always been a little bit shy, but I can put an end to your fears. Let me show you a play.
First of all, I would like to make sure that, am I audible to you all? Guys, give me some signal so that I can get to know that you people are there. Oh, yeah. I got your response. Thank you so much for that. Again, I welcome you all and thank you very much for joining our live session. We support and help GCSE students. This is just the beginning, and we are planning to expand this thing in other subjects too. And I'm really confident about this, that you people will find this session really fruitful and you will be able to get subsequent benefits out of this session. Still, if you people are comfortable, you can just switch on your camera. And just by keeping your mic mute, you can switch on your camera so that I can see that you people are there and enjoying my session. Okay, let me tell you one more thing, student. Today we are going to do chemistry, and in chemistry, we're going to talk about a topic that is a really difficult topic. I have found throughout my experience that students find this topic a difficult one. So if you people got any query within the session, you just write down your queries in the comment box, and I'll try to answer your queries during the session itself. Otherwise, if my back team will try to answer all your questions within the session. So students, we're going to talk about the titration, which is considered as an important topic and as well as a difficult one in field of chemistry. But before moving to titration, it is really necessary to talk about some basic concept, because without that, you can't do anything. So what are learning objectives going to be throughout the session? First, what do you mean by the term concentration? And what is titration? And what is the process involved in it? I hope now you people are looking at the images that is given, and you must be recalling if you have done this in your school. And you must be finding out the problem you would have faced during your school. So don't worry, I'm there to help you out. I'm there to help all your queries. You just keep on enjoying the session. Okay. So before starting with the topic, as I said, there are some few basic things that is need to be in your knowledge. Then only we can move on to the topic titration. So the very first thing that comes is the concept of moles. So, and then concentration. I mean, you must have done this before, but can I get an idea? Is there anyone who have a little bit of knowledge about moles and concentration? See, if you know anything about this, you can just, okay, you do, that's great. I got one response. Is there anyone else who know about moles and concentration? Yes, I got one response. Is there anyone else? Okay, there is one more. Okay. So may I know your name, please, so that we can have a cheer up for you. What's a good name?
Nidal.
Nidal. Okay, Nidal is the one who gave me the response that he know about moles and concentration. Okay, there's one more, that is Alia. That's great. So see, students, if you need to, you can switch on your mic if I ask you to respond, okay? Okay, so there are a few students who know about moles and concentration. Let me make it a little bit clear to you if you have some doubt in it. Okay, when I say moles, moles is basically a unit to measure the amount of substance. It is a unit in international system of units. Okay. And if I talk about concentration, before that, I just have a view at something that will make more clear things. Okay. Yeah. So I said moles. When I said moles, as I said, it's a unit to measure amount of substance. Here, I'm going to give you a very good trick to calculate number of moles if it is given in mass. If you are provided with volume, then how you can calculate moles. So just if you have your pen and paper with you, please write down this trick because this is going to help you in all of your years. Okay, students? Moles. In some of the questions, you will be given with the amount of substance in grams. That means you will be provided with mass of that substance. They can ask you, what is the number of moles in that substance? They gave you mass and they're asking you to calculate moles. So how will you do that? Please give a focus on the arrows I have drawn. Yeah, I think this is more clear now. So if they have given you moles and they're asking you to calculate mass, the only thing you need to do is you need to multiply those number of moles with the molecular weight. What you need to do? You need to multiply the number of moles with the molecular weight and you'll get the mass. Again, if you are not given with number of moles, you're supposed to calculate that. What you need to do is just to divide your mass with the molecular weight and you'll get your number of moles. We'll apply this thing right now to make it clear that my strategies and my quick tips are working. Okay, so please do it with me, or if there is anyone who is interested to do it before me, is there anyone? Yes, Nadal, are you interested to do it right now?
Yes. Let me just get my calculator.
Okay. Yes, Alia, you're also familiar with the concept. Will you try it now? At the end, I'm there to tell you the answer. Don't worry about that. I'm there. Okay, she's doing
0.2 for number one.
0.2.
2.
Okay. What will be the units? What actually we are calculating right now? Yes,
Moles.
tell me the exactly moles. See, our answer remain incomplete if we are not writing the units. It's really necessary. Let me tell you, it's really, really necessary whenever you are doing any question in physics or either in chemistry or in mathematics too. You need to write down the units. That otherwise your answer is incomplete without that. So,
question 2 is 330 grams.
Okay, you have calculated the second one. Okay. Okay, we have one more with us. Yes. Alia, have you got your answer? We have some other participants too. Aren't they trying it or they're not getting it? If you people are confused even a bit, just let me know in the comment section. We are there to solve all your queries right here. Yes, let me tell you how Nidal got this answer. As I said, what actually is given here, just look at the question first. Find out the number of moles of sulfuric acid molecule in 19 grams of sulfuric acid. So basically, they're asking you to calculate the number of moles. Okay, so there is one more. She got the answer. It as 0.2 moles and 315 for the second one. More students are giving the same answer. That's great. Good, very good. I'm liking it. Yeah, great. Your response is great. Okay, I just saw that there is something like 330. How you're getting 330? I'm not able to get it. Hiral, please focus or somewhere you have committed some wrong. Okay, so how you'll get this? Let me make this question clear to the students who haven't done it till now. Students, we are supposed to calculate the number of moles of sulfuric acid. They have given us the mass. So mass is 19.6 grams. Okay, mass is 19.6 grams. And we know molecular weight is 98 AMU. And we need to calculate the moles. That is really, really easy. You don't have to do anything. You just divide the given mass with the molecular mass. And here you are with your answer. Isn't it easy? Okay, let's come to the second question, as most of my students have given the right answer, but still, I'll do it for the one who are a little bit behind. It's totally fine. You will be with me. You all will be with me at the end. So you need to calculate the mass of 5 moles of nitric acid, where they have given you the molecular mass of nitric acid, that is 63 AMU. Again, go back to the strategy, what I have written, that if you're given with number of moles, what you need to do is just multiply it with the molecular mass. So that will be 5 times 63. So that is going to be 315. What will be the units? Is there anyone who is going to give me the answer?
Grams, 315 grams.
Exactly. That's great. Okay. Yeah. See, if there is anyone who is getting confused, all your queries are, solved in the comment box. Okay. I hope this concept is clear to all. So without wasting time, let's move on to the next thing, that is concentration. This one is really, really easy. But this is not the concentration I'm asking you people to do right now. It is the concentration in case of chemistry, okay, with respect to solutions. So when I say concentration, I hope you all people must get something in your mind. Yes? Do you got something in your mind when I say the term concentration? Yes? Okay, my students are responding. Yes. So it means, again, you have a little bit knowledge about concentration. Let's make it more clear. Okay. When I say concentration of a solution, that means, it may be expressed as the amount of solute dissolved in a certain volume of solution. Let's say I have some amount of solution in a glass. Okay. I have some amount of solution in a glass, and if I say, what is the amount of solute I have dissolved in this glass? Okay, are you getting it? What amount of solute? Solute is that solid thing that we're dissolving in the solution. Okay, that is we are dissolving in the solvent. Solute plus solvent gives us solution. So what is the amount of solute in that solution is going to be known as the concentration of that solution. Okay. So let me give you a very really easy, let's say, please pardon for my bad drawing. I'm not that good with drawings. So please, I'm so sorry for that. Still, I'll try to draw as much as possible, like as neat as possible. So let's say I have 2 glasses, though they are not of same size, but they are. You need to assume it. Please do it for me. So we have 2 glasses. And let's say in one, I have taken some amount of solute. This glass contains some amount of solvent. And I mix the solute in the solvent. Now this glass is containing a solution. Let's assume my solute is, we can consider as salt. Okay, let's say I have salt and my solvent is just water. Okay. So right now, I don't know, or you can say how much amount of salt I have dissolved in this water is going to be the concentration of my solution. Okay, I hope this example made everything clear. Yes. Is there any query on concentration of a solution? Still, I have one more example to show you. Okay, have a look at the diagram here. Here, all these glasses are containing H2SO4. So before going to something else, would you like to tell me what is H2SO4? I hope you all must have seen H2SO4 in their labs. Sorry?
Sulfuric acid.
Yeah, that's great. It's sulfuric acid. H2SO4 is sulfuric acid. You all must have seen in your labs. Maybe right now you're confusing or you're not able to get it. Okay, that's great. So all my containers are having H2SO4 in them, but still you'll see there is a difference in color of all the glass. As I move on from left to right, the color intensity is increasing, isn't it? Why? What's the reason? The reason is, as I'm moving from left to right, my concentration is increasing.
pH increases.
Yeah, that means the amount of solute is increasing as I'm moving from left to right. Okay, I think it's clear. Okay, and we have a formula to calculate the concentration, that is amount of solute that should be in grams divided by volume of solution. I think things are clear till here. Okay. Okay. So these were the basics that should be clear in one mind while doing titration. And here is our actual topic that we're supposed to do today. So would you please tell me how many of you think titration is difficult but interesting as well as? Yes. Or is there anyone who have performed this experiment in their labs? Yes. Okay, titration is easy. Okay. One of my students saying that titration is easy. Okay. Okay. Let's make it easy. If it's only easy for one student, let's make it easy for all of you today. Okay. So as you can see, the setup is really colorful, and it is in actual also, it is really colorful and really interesting. Let's have a look what exactly it is. So before we do any experiment, let me tell you it for everything. This is not specific with titration. This is for every experiment you're going to do in your, in your subject. Let's say, whenever you do an experiment, there should be some questions in your mind, and then only you will be able to do that in a perfect way. That is, very first thing, what, how, and why. What is that? What is basically your experiment? Or in reference to titration, we can say that, what is titration? Why are we doing titration? And how we can do titration? These questions should be always in your mind whenever you are doing any experiment. Okay? Let's start with this. Okay. The very first thing, that is the principle of titration. So what exactly titration is? Titration is basically an experimental technique that we do in our labs. Why? Because let's say we have a solution. Okay, I have two flasks in my hand. The solution, the concentration of one solution is known to me. I have everything, like I know everything about my solution, the volume, the concentration. But on the other hand, I have one more flask in my hand, but this time I don't know the concentration of this solution. There, the titration comes into action. Okay. When I know the concentration of one solution, but I don't know the concentration of the other solution, there comes my titration process. Okay, students? I hope the use and the principle is clear to you. You can switch on your mic and just give me a response so that I can come to know about this. Yes. Okay. So if you people have a pen and paper with you, you can just write down the important things out of the slide, because this is going to help you in all your years. This question comes in approximately 3 marks. Like they can ask you about the principle, they can ask you about the procedure, they can ask you about the molarity, the molality concept. So it comes in all of the years. So you can just write down the important things from here. Okay. The next thing, if you know the accurate concentration of one solution, then once the endpoint is established, the balanced chemical equation gives the number of moles in a certain volume of solution. Now you will say that everything was going on so easy, then why you have introduced such a big, definition, and that too complex? So let me tell you, students, you yourself say at the end that now we got what actually you're trying to say in the beginning of the session. Okay? For that, you need to go through this. Okay. The next question, the next thing that comes in mind is, what are the equipments that are required to perform the process of titration? So you can see there are a few equipments in front of you. Let's get introduced, all of them. They are our friend in chemistry lab. We all encounter all these equipments in chemistry lab. So is there anyone who can tell me what is the image, the very first image? What is the name of this
Pipettes.
instrument?
Pipettes. The next
Okay,
is a
that's
conical
right.
flask. And the third one is a burette attached to a clamp stand.
Yeah, that's
Positioned
great.
over a conical flask.
That's great. Yeah, that's great. Okay, some of my other students are replying me in the comment section. I'm so sorry if I'm reading out your section. Your message is a little bit delayed. Okay, that's great. So it means you people are like some of you are familiar with the equipments. Okay. The very first is pipette. As you can see, there are little marking on it. These are for, to get the exact volume of any solution which we need. Okay. This one is your conical flask. And this is burette plus stand. Okay. You were able to answer me the names of the equipment. Can I get a little deeper on this? Can you please tell me this part of the stand? Can you name this part of the stand?
Clamp.
That's great. Yeah. Okay. What about this? Yes. Is there any? Okay. Is there anyone who can tell me? I know Niddle is really well familiar with the concept. That's really great. Is there anyone else who can tell me the name of this part of this stand? Sorry, it's a part of burette. So is there anyone who can tell me the name? Yes. I'm expecting some answers. Yes. Okay, it's okay. I'll answer this. Well, I got this answer from Nidal, but I was expecting this from some other students too. Okay, this is our, can you just repeat it, Nidal, what it is?
Tap.
Exactly, it's a
Tap
stopcock.
to allow the acid to drip through.
Exactly, that's right. Yeah, it's a stopcock. So let me tell you what exactly we are going to contain in each of them. So those who are a little bit confused with the things and are not giving me answer right now, so they just write it down so that it can help them the next time they'll do this topic. So this will, which one is going to contain what? So this helps. This helps in measuring certain volume of solution. Because there are markings on this puppet, so as much as amount we need, we just take it with the help of puppet, and then we can, transfer it to some other thing. So that here we use this for transferring our solution in the conical flask as well as in the burette. Okay. 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 So the next thing is that we need in this process is indicator. This is again a really important part of this thing. If you are not aware about indicators, that means you only know half of the things. So don't remain on half of the things. You have to do each and everything, because I think, okay, before going to this, will you please tell me how many of you are here from year 9? Is there anyone from year 9? Yes, students. Is there anyone from year 9? Write down yes in the comment section. Okay, I'm not getting any response regarding this. Is there anyone from year 10? Okay, there is one. Okay, there is one. Okay, is there anyone from year 10? Okay, there's one more in year 9. Okay.
Yes, hun.
Okay, you are in year 10.
Wait, miss,
Yes.
I'm not in year 9, but like, do you mean you're in year 9 before summer holidays or after when you go back to school in September?
Uh, it's totally fine if you are going to be in year 9 or you are in year 9.
Okay,
Yeah. So you're
I'm
going
going
to
to be
be in
11.
year 9 after summer holidays, right?
No, I'm going to be in year 11 after summer holidays.
Okay, okay, you're going to be in 11. Okay, that's great.
Yeah.
Okay. So the one who are not responding anything, I think they all are in year 11. Okay, let's move on to this then. Without wasting time, let's move on to the indicators. The very first thing when we talk about indicators is what exactly indicators are. So when I say indicators, you must got a hint that it is something that indicates something in the process. Well, you're right, it is something. So it's basically a substance. It's a substance that changes color in response to the medium. When I say medium, it means acidic or basic medium or neutral medium. Okay. So in the process of titration, we can use 3 types of indicators. One is natural indicators, other one is your self indicators, and the third one is your outer indicators. I'm going to tell you one example of each of them and how they behave in what kind of medium. The very first indicator is natural, which is turmeric. As you can see, the turmeric is enjoying at one corner. The turmeric is really happy as she is playing a really, really important role in the process. She's like, turmeric is really happy. So turmeric acts as a natural indicator. It is naturally available in the environment. Why it is behaving as an indicator? Again, it's a really important question. Why turmeric only? Why not other thing? So let me tell you, we have some more examples of natural indicator. For example, we have a red cabbage, but most of the time we use turmeric. You can use red cabbage too, but we prefer turmeric. That is because of a presence of a yellow chemical in turmeric, that is curcumin. It's a yellow chemical present in turmeric, which changes its color with respect to the medium. Okay, so if it is available in acidic medium, it remains yellow in color. If we put turmeric in basic medium, it changes its color. Okay. Right now, I will not answer which color it will turn into because I would like to ask you one incident. If any one of you have faced it in your, daily routine life. Sometimes when we eat something, okay, that we eat some food that contains turmeric and it somehow accidentally falls on our dress. Okay. And we go to the what we really do in that situation. We just rush to the washroom and we try to, remove it from our clothes, right? So have you ever noticed as soon as we apply soap on that, cloth, the color of that, stain changes into some other color. So is there anyone who have encountered the situation ever in their life? Okay, one of my students saying orange, like he is approximately near. For once, I can consider this color if there is no other response from anyone. Is there anyone who have encountered this situation in their life? Yes. Yes. I'm waiting for your responses, student. Okay. No more. Okay, there's one more. That's great. Okay. Again, if I combine all 3 of you, I'll get my exact answer. Now, this is a clue for you. If I combine all three colors together, I will get the exact color. It's a hint for you. Okay, it's a kind of, investigation kind of thing. So you have, all of you have your hint. So is there anyone who can come up with the right answer? Okay, let me tell you, I got response like orange, red, yellowish. And I'm saying if I combine all three color, I'll get my exact color. So is there anyone else who can tell me the right color? Okay, if there is no one else who is giving me the right answer, I'll credit this answer to these two students. That's great. Okay, so let me tell you the exact color is reddish brown color. Whenever turmeric encounters the basic solution, it converts into, the color changes into reddish brown color. So you all, like both of you were really near to the answer. That's great. Reddish brown. Okay, the next indicator we have is a self indicator. So you all must have got the hint what exactly I'm going to tell you. This KMNO4. KMNO4, we call it as potassium permanganate. What do we call it as? Potassium permanganate. Okay. Again, it changes color. So is there anyone who can tell me the color of potassium permanganate? Yes. Initially, it remains violet in color, but as a change in the medium, it changes into colorless. Yeah, initially it is purple in color, purple, or I can say violet in color, but as soon as, the reduction reaction takes place, it changes, the color changes into colorless. Okay. So you can say it is purple. And then it converts into colorless. I can better write down the equation that is KMNO4, where it reacts with the iron. It converts into Mn2 positive. So here it is purple in color, but as soon as it reduced into Mn2 positive, it converts into colorless substance. Okay. Now, the next one, this is really, really common indicator. Oh, you all must have seen it in your labs. Also, we use it in biology experiment too. Like it is really, it is more frequently used in biology experiments too. Okay. Okay, let's do it with this. So the next color, the next indicator we have is phenolphthalein. Have you ever heard about this? Yes?
Yes,
Okay.
that's
it
the
is-
indicator we use in titration.
Exactly. So is there only one student who have used this indicator in their labs? Or is there someone else also? Yes. So phenolphthalein changes its color to base, like it converts into pink color when it encounters a base. Yes, grades, good grades. When I say good, yes, is there anyone who have any query in their mind? So this is the way you all have seen how I was teaching you and how all your queries are being sorted out throughout the session. This is the way we do things. All your queries are solved out throughout the session, within the session. Also,